Now just I will start with the second problem of this maximum power transfer theorem. First convert this given network into the Thevenin's equivalent network first. Now first I will write converting above network into Thevenin's equivalent network. First, we will apply the steps for this conversion. What are the steps? First, remove the load resistance and redraw the same circuit. Is it right? I will write here. Removing load resistance and redrawing the same figure. Redrawing the same circuit. Is it right? And then we will try to find out its VTH. In this case, if I am drawing the figure, I will remove this. I will redraw everything. This is 2 ohm. Here it is 2 amperes. Here is one resistance. This is another source. And here it is the 5 ohm. This point is the B point. This is B point. This is A point. This is the current source, which is 2 amperes. This is the current source, which is 3 amperes. Here it is the 2 ohm. This is 3 ohm. And this is 5 ohm. Is it right? So here in this case, I will come back to you how to find out the value of VTH. Which method we will use, because we are interested in the calculation of this potential. We cannot use this path. हम ये path use नहीं कर सकते हैं. We cannot use this path. Because we can calculate the voltage across this, but we are not in a position to know the voltage across 2 ampere directly. Otherwise, we are also not able to use this path. We are also not able to use this path because we don't know the voltage across 3 ampere current source directly. That's why we have to use another path, and that path should not consist of the current source while calculating the voltages. So here in this case, if we are interested in the calculation of the VTH, we have to use this path. We have to use this path. Which indirectly we are interested in the calculation of current in 5 ohm, 3 ohm and 2 ohm. And then we will use this path, and then we are in a position to find out its value of the VTH, which is nothing but the Thevenin's equivalent voltage. Thevenin's equivalent voltage. Now here, which method we have to use for the calculation of the current, in this case, in this branch as well as in this branch? Which method we will use? I will come back to you. Yes, anyone? Anyone is able to answer this question? Avinash?
Yes, sir.
Which method we will use? Okay, fine. I will come back to you later. Chaya?
Yes, sir.
Which method we will use to calculate current in this first loop as well as in the second loop?
Node analysis.
Node analysis. Absolutely fine. We can use the node analysis. That is one case. Any other? Any other method? Okay. I will come back to you later. Madhuri? Rishikesh?
Yes, sir. मेश यूज कर सकते हैं सर.
क्या?
मेश एनालिसिस.
मेश एनालिसिस यूज कर सकते हैं. कैसे करेंगे यहाँ पे?
सर करंट सोर्स बाहर है तो 2, 3
ये हुआ I1, ये हुआ I2. लेकिन यहाँ पे KVL अप्लाई नहीं कर सकते ना?
सर कर सकते ना.
कैसे?
सर करंट सोर्स बाहर है ना सर. लेकिन सर डायरेक्ट वैल्यू आ जाएगी ना सर करंट.
Absolutely correct. Bilkul sahi. Now here in this case, no need to use any other method. Here directly you will get the I2 is equal to 2 ampere and I1 is equal to 3 ampere. We can use the nodal analysis method also. This will be the node 1, this will be the node 2, this is one branch, this is second branch, and this will be the third branch. Is it right? Is it right? इस ब्रांच में करंट कितना रहेगा 3 एम्पियर. इस ब्रांच में करंट निकाल सकते हैं, इस ब्रांच में करंट. We can use the nodal analysis, but in place of going in those complications here, directly we have this I2 is equal to 2 amperes and this I1 is equal to 3 amperes. Absolutely fine. So here from above figure, what we have? What we have here? From this figure we have the direct equations. What are the equations? This I1 is equal to 3 amperes. This is equation 1. And I2 is equal to 2 amperes. This is the equation number 2. Look at here. How I have taken this current direction. I2 का direction मैंने इसके हिसाब से लिया. If I have taken this clockwise, इसको अगर मैं clockwise लेता, तो this current should be the minus 2 amperes. Generally ये minus sign लेना हम भूल जाते हैं, इसलिए what I suggest that you should always assume the direction of the current in that branch or in that loop same as the current source. Otherwise, we have to take here the sign as minus. Now we have the I1 and I2. Now we are in a position to find out the value of VTH. How is the VTH? Now I will travel from the B towards A using this path. I will mark the polarities first. This current is clockwise. It is a plus. This is minus. It is downward. It is plus minus. For loop 2, how are the polarities? It is anti-clockwise. Means this is plus. This is minus. This is plus and this is minus. Is it right? Now I will find out the VTH here. This is modulus. We are traveling from the B towards A. We have to use only this path. There is no other choice. If I am using this path, we are traveling from negative to positive, which is a plus. This is plus. Its resistance is a 5 and its current is a I1 because this is the loop 1. Its current is I1 and which is 3 amperes. Then for this branch, we are traveling from negative to positive, which is a plus. Its resistance is a 3 and how much is current? Both current are in the same direction. Both currents are in same direction. That's why its resultant current should be I1 plus I2. That is the resultant current in this case. Is it right? Are you getting me? In this case, the resultant current will be the same value. Similarly, if I am coming back negative to positive, which is a plus, its resistance is a 2 and its current is a 2 amperes. That's it about this, which is equal to. This is, I will put it as 5 into 3 plus 3 and its currents are I1 plus I2, which is I1 is a 3 amperes plus I2 is a 2 amperes plus it is 2 into 2. Simplify this equation and find out the value of the VTH. Yes. How much? I guess this is 15 plus this is 15 plus 4. I guess it is 34 volt. Is it right? 34 volt is the value of VTH. Sahi hai?
Yes, sir. Correct.
Yeah. If we know the value of the VTH, now for the calculation of RTH, what we will do? For the calculation of RTH, we will remove the load resistance. At the same time, we will remove the sources. And these sources are the current sources. Internal resistance of the current sources is infinite. Then how will be the figure? I will write it first. For calculation of RTH, we will remove load resistance and all sources are replaced by respective internal resistances. Respective internal resistances. How will be the figure? This will be the figure for the calculation of RTH. For the calculation of RTH. This is point A, this is point B, this is 2 ohm, this is 3 ohm, and it is 5 ohm. The current source in this point is replaced by its infinite resistance, and this current source is also replaced by its infinite resistance. Now calculate its RTH, which is all these three resistances are in series, that is 2 plus 3 plus 5, which is, I guess, it is 10 ohm. This RTH is the 10 ohm. Is it right? Now look at, this problem is looking to be very same as the previous one. But look at how the calculations are different. That I am trying to show here. So here in this case, if we know the VTH and RTH, then complicated network is replaced by Thevenin's equivalent network. I will write the same here. Now, complicated network is replaced by Thevenin's equivalent network. How is the figure? This is the figure for Thevenin's equivalent network. Reconnect the load resistance, which is RL. We are interested in this calculation. How much is the value of RTH? 10 ohm. This RTH is 10 ohm. How much is the value of the VTH? VTH is 34 volt. This is 34 volt. Now we can apply the maximum power transfer theorem. Now, as per the maximum power transfer theorem, this RS is equal to RL, which is equal to 10 ohm. Now we know the load resistance now for maximum power transfer. For maximum power transfer, this load resistance is 10 ohm. Now we will find out the Pmax. For that case, we have to calculate this current, which is the load current IL. Now if I am calculating this value of the load current IL, which is 34 divided by 10 plus 10. It is 34 divided by 20. Calculate this current. Yes, anyone?
1.7.
1.7 amperes is the load current. And if we know the load current, we can find out the maximum power transferred to the load, Pmax, which is equal to IL square into RL, which is 1.7, its whole square into RL, which is 10. How much?
28.9.
28.9 watt is the maximum power which is transferred to the load as per this particular theorem.